We now move slowly to our next topic, and that is about the future of circular buildings, and that is powered by Drees and Sommer.
Yeah.
Do you have it on there as well?
Yeah. Drees Sommer, a European leader in real estate consulting, project management and planning with an extremely strong focus on sustainability and innovation for over 50 years.
Yeah.
I think that's worth actually commenting on because sustainability has just kind of come back on the radar. So that's huge. They're pioneering the implementation of circularity through their cradle-to-cradle design principle. Marco Abdallah, Head of Engineering at Drees Sommer UK, joins us for the next keynote on future of circular buildings. And he will take you through their innovative solution and share practical examples where they have successfully implemented circular buildings. Marco brings extensive international experience, having worked in Germany, China, and the UK.
Wow.
Marco, are you with us?
Yes, I am. I hope you can hear me.
Yes, we can hear you, and we're very excited to hear what you have to say and share some of your expertise with us. Do you have a presentation to share?
Yes, and I think you should be able to see it now.
Yes, we can.
Excellent.
Beautiful.
Thank you for introduction. It's really my pleasure to present the topic Future of Circular Buildings. My name is Marco Abdallah. I'm based in London, heading our sustainability and engineering approach for the UK. And I would like to show you in the next 15 minutes, I know it's quite short, but I want to show you a few case studies where circular economy principles were deeply integrated into construction projects. I think to a level where a new type of architecture evolves, which follows a very holistic approach towards sustainability. And so when we talk about sustainability, we very often move into discussions about zero carbon, because obviously we have a global warming problem, which is certainly one of the biggest challenges of our generation. But in the shadow of the climate crisis, we see a waste and especially a resource problem evolving. And both topics, global warming and the waste and resource challenge, are deeply interlinked, which you will see, I think, in the next few minutes very clearly. For the ones who like numbers and stats, including myself as an engineer, the statistics show very clearly that our construction sector is part of the problem. Our buildings are responsible for around 33% of the global carbon emissions. At the same time, our buildings consume around half of the total raw materials, and consequently, our building sector is also responsible for around about 60% of the total waste. Now, to understand the problem, we need to look into the full life cycle of our buildings. That starts with the raw material sourcing, the construction, what we often refer to Module A, the cradle-to-gate approach, also including operation and maintenance, including then also the end of life with the demolition and the disposal of our building. And beyond that, we see Module D, where it comes to refurbishment and recycling of materials. And that's then the full cradle-to-cradle or circular economy approach. Now, we have done a couple of carbon life cycle assessments here in the UK, and you very often see a similar pattern regarding the distribution of carbon emissions. Here is, for example, the footprint of a large-scale tower in the city of London we have recently analyzed, and you really see that around 40 to 65% of carbon is operational carbon, and the other half, 35 to 60%, is embodied carbon in materials. And now if we talk about net zero carbon and we only address the operational carbon side, we only tell half the truth. Because at that initial, at the initial phase of our life cycle, which you see here on the left side with the blue bar, we have that massive peak of embodied carbon emissions here in blue. And over the life cycle towards the right in orange, a relatively constant band of operational emissions from heating, cooling, and the energy we consume. Now, we see a decarbonization of the grid, which helps to reduce the operational carbon footprint over the next decades. But it has a very limited effect on embodied carbon because we first import often the materials we use from other countries where our own decarbonized grid doesn't really help us. And second, we need to consider the fact that, as mentioned, and as you see, most of the embodied carbon is happening now. It's happening at the initial construction. So it doesn't really help us if we have a decarbonized grid in 20, 30 years, because the carbon emissions are already emitted today. So it's a topic we have to address very urgently. The logical approach is obviously first to avoid emissions from start by refurbishments instead of new construction. And second, to reduce emissions by new design principle. And that brings us to circular economy, because circular economy has the potential to cut embodied carbon by around 45%, which is really a lot. So our mission, as you mentioned already at the beginning, is to really help our clients in the transition from a linear economy to circular economy. Today we live in a world of linear economy where we take, we make, and we waste. When we talk about recycling, in most cases it's a form of downcycling. Example is a window with a very high quality glass. When you recycle that, it often becomes first a green beer bottle. If that is recycled a couple of times, it becomes a brown beer bottle, and ultimately probably becomes foundation material, or it goes to the landfill. So you principally postpone the way to the landfill. And if we achieve a full circular economy, all materials of our window can be used to produce a new window because it was initially designed for that purpose. And then material loops are closed, and then waste would not exist anymore. Now, this requires that we completely need to start to rethink the way we see and create our urban environment from an urban level to a molecular level. We have to see our cities as material storage. Means we can add materials into the storage, but we can also source raw materials from our urban environment to make new buildings or refurbish them. And therefore, those buildings have to be designed for disassembly. The products need to be recyclable. That requires recyclability on component level, which very much depends on substance and molecule level, in the end, the chemistry behind our materials. To introduce that know-how into a project and to activate it within the project team, we need a new role in our design and construction process. We call it circular engineering. It addresses the three key topics of cradle-to-cradle buildings. First, recyclability. Second is flexibility and design for disassembly. And the third key topic is the use of healthy materials which are free of pollutants. And I think that also describes the secret and the precondition for upcycling of products and also entire buildings. Now, I want to show you how that looks in reality. We had really the luck to be part of the project RHE in Essen in Germany. I think it's a very impressive setting, a former coal industry district, which is repositioned. And that was a pilot project of the initiative Horizon, I think 2020, by the European Union under the BAMB, the Buildings as Material Banks approach. And consequently, the building was designed following cradle-to-cradle principles throughout the entire project. And it's finally one of the first projects where so-called building circularity passport has been developed. We used the cradle-to-cradle design principles, which you see here on the left side, to select, for example, the right facade system. And in the end, it is a ventilated cladding. It's not rocket science, which is good because we want it to be an easy, adaptable solution. And it's simply a steel concrete wall with insulation, rain protection, with aluminum cladding mounted on the substructure. So the difference is now in the details. We use different insulation material. The cladding can be disassembled. Nothing is glued together. It's mechanically fixed, and the material and the components are recyclable. And in the end, thereby you achieve an up and recycling rate of around 39%, which is really high. And you still manage to keep all remaining materials in a downcycling loop, the 61%. You don't need to bring anything to the landfill anymore, nor to an energetic incineration plant where materials are burned. And the advantage gets very obvious when you compare it with a conventional composite insulation systems, where often more than 20 layers from the wallpaper, plaster, and so on to the outdoor paint is glued together to one piece. And there you can't upcycle or recycle more or less anything, just 1%. You can downcycle 60%, but 31% needs to be burned, and 8% can't even be burned because it's too toxic. So there is a huge impact in the end you can make. And we see that also digital technologies are really an enabler for circular economy. They can boost the topic. We have analyzed that in our project, The Cradle, which is designed by HPP architects and developed by Interboden. So it's really a developer project with a very strong focus and aspiration towards the financial business case. And I think the key topics we were able to introduce here were the use of natural materials. That starts with natural clay instead of plaster. Many building components are made of timber, for example. You see here the external hybrid timber structure. We have timber slabs and timber walls. I think the exceptions are the basement and the ground floor level, which you see here, and the central core structure. Beside the use of natural materials, the second key topic was separability and design for disassembly. So neither are adhesives or irreversible material mixtures used. Instead, all components are installed using screw connections or anchors. So the building at the end of the lifetime can be disassembled and parts and materials can be reused in other projects, recycled, or are biodegradable. So it's really circular and waste has been minimized to an absolute minimum. I mentioned before digital technologies. To optimize and monitor the material performance in the construction process, we integrated parameters into a circular BIM model, which you see here on the screen, and which is an approach we developed over the last years, and that really helps to visualize material performance. For example, recyclability, separability, the healthiness of materials, or embodied carbon. Basically, everything is possible. And I believe it's a very straightforward approach to focus on the components with a simple color scheme, which make the greatest impact in terms of material sustainability. And when you do that job of establishing a circular BIM model, you also have already created a material project database, which then can be used to develop a building circularity passport. And this document for us is really crucial because it provides transparent facts with a dashboard and the KPIs about the material performance, like healthy materials, how much of your project or of your building can be recycled, what's the separability rate, what is the embodied carbon footprint. And I think that will in the future directly affect also the financial value of an asset. This information can then be published on digital platforms such as Madaster. I think Madaster is also part of a panel discussion this afternoon, where they might give you some insights into that topic. And such platforms principally allow you to map resources inside an urban environment, which is the basis for urban mining, sourcing raw materials from existing buildings. And that's the circular economy approach we use for renovation and refurbishments. Each building contains a lot of raw materials, which can partially be extracted. And it's actually a no-brainer. Instead of sourcing new raw materials from the other side of the world with very energy-intensive mining processes, we can simply extract a lot of raw materials already from our urban environment. And by doing so, we solve the waste problem, we solve the resource problem, plus we significantly reduce embodied carbon emissions. And I think that has been very successfully implemented in the World Trade Center project in Brussels My colleague Michael Moradielos is also part of the event today and probably will say a few words to that project. I would like to close the presentation with an information which I think is very relevant for investors. We know that sustainability approaches are only successful in the long term and in a large scale if they are either enforced by regulations or if they come with a profitable and good, attractive financial business case, which we have because cradle to cradle buildings are able to maintain so-called residual value. And if we take, for example, a conventional building here in dark blue color, of course, at the beginning, it has a positive financial building value, but with time and use, this value decreases. We can temporarily bring it back through or increase it through renovations and refurbishments, but at the end of the lifetime of the building, it becomes a financial liability. We need to pay for demolition, we need to pay for the landfill, and that's different with cradle-to-cradle buildings. At the end of the lifetime, we, here in light blue color, we can principally disassemble the building, we can sell the parts, and we can sell raw materials. So it becomes not only an investment in a real estate asset, it's also an investment in the end in raw materials. And that's the residual value, which typically equals the raw material value of the building. And in our last projects, I think we always achieved a residual value of over 20% of the original invest. And that has a huge impact on the business case, also starting from a higher return rate from day one. So I think it really starts to get profitable. That's why we are very convinced that circular economy will make its way into our building projects. And we believe it will also bring us the next revolution in the construction sector, which would help us to solve climate change, waste, and our resource challenge. Thanks for your attention. I would like to give back the screen.
Yeah, thank you very much, Marco. There was some amazing insights and also some amazing case studies on how well the circular economy is really taking place in real estate. So thank you for your presentation.